Hey, welcome back to your favorite calculus class. We're going to take a look at derivatives of trig functions. So first of all, the derivative of the sine is the cosine, and you know what? Let me tell you why here. If you have f of x equals the sine of x, and you're trying to find that derivative by using that limiting process, then what you have here, limit h goes to 0 of sine of x plus h minus the original sine of x all over h. And then if you remember this identity, the sum identity, sine of u plus v is sine of u cosine v plus cosine u sine of v, if you remember that from trigonometry. I'm going to apply that right here. So my u is my x, my h is my v. So this just ends up being the limit as h goes to 0. And don't get too worked up about this. I just want to show you where this comes from. Okay, sine x cosine h plus cosine x sine h, and then minus our sine x right there. It's all over h. Now I'm going to go ahead and I'm going to take a sine x out of this one and this one. I'm going to factor it out of those. So I have sine x, I'm left with cosine of h minus 1. Over here I have cosine x sine h. It's all over h. Now I've got a sum here, so I can write this. I have a summation here, right? I have this term over h as well as this term over h. I can split that up, in other words, because that's a common denominator. It means I can split up the limit. Let me take it up here. So I have limit h goes to 0 of sine x cosine h minus 1 over h plus limit h goes to 0 cosine x sine h all over h. Okay? Now what I can do is I can take the sine of x out front. Okay, that's just a quantity there. It's just sine of x, whatever x is, cosine of x. I could take that out front. So I have sine of x times the limit as h goes to 0 of cosine h minus 1 over h, plus over here I have cosine x, and then I have the limit on this sine of h over h. Now these were special limits that we had. This limit is just 1, right? If you remember, it's been a long time, but we had a limit as x goes to 0, sine x over x is 1. And then this is a special limit that we looked at briefly, and this limit is 0. So I have sine of x times this 0 plus cosine of x times this 1. Well, that's gone. I'm just left with the cosine of x. So f prime of x is cosine of x. So the derivative of the sine is the cosine. That's your proof of that. So just remember, derivative of the sine is the cosine. You could do a similar process for the cosine. The derivative of the cosine is negative sine, and this is just showing if this is f prime. If you remember when we analyzed f and f prime, for the cosine, at 0, our slope is 0. The slope of the tangent is 0, so f prime would be 0. Slope of the tangent 0. Slope of the tangent right there is 0, and so on. Anyways, the derivative of cosine is the negative sine, right? Negative of the sine. Derivative of cosine, negative sine. So let's go ahead and solve these. Let's do a y equals 2 sine of x. So y prime would be constant, stays there. This is y prime. Derivative of the sine is what? Cosine. B. Notice b is sine x over 2. Instead of running the quotient property, I'm going to write that as 1/2 times the sine of x, so that when I take that derivative, it's just easier than running the quotient property. I leave the constant there, and then I take the derivative of the sine, which is cosine. So 1/2 cosine x, or cosine x all over 2, however you want to write that. C, y of x equals x plus cosine of x. So y prime of x, derivative of x is 1. What's the derivative of the cosine? Negative sine. So this ends up being 1 minus the sine of x. That's y prime of x. D, you got the derivative of, I'm going to write it this way, derivative of cosine x minus pi thirds sine of x. Derivative of the cosine, negative sine. Leave that minus pi thirds constant there, then take the derivative of the sine, cosine. So negative sine x minus pi thirds cosine x on that. All right, the cotangent. Now there is a rule for this. In fact, we'll develop it here, but the cotangent, if you're taking the derivative of the cotangent, isn't that the exact same thing as taking the derivative of the cosine over the sine? Say sure it is. So let's go ahead and run that. Let's see what we get. This is the quotient rule. So I'm going to say derivative of the top times the bottom. Leave the bottom alone. Minus the top times the derivative of the bottom. Now what's the derivative of the sine? Cosine. All over bottom squared. So we've got negative sine squared x minus cosine squared x. This is all over sine of x, quantity squared. I'm going to take a negative out of both of those because I'm seeing, oh, that's sine squared plus cosine squared. There's my money formula. That's 1. So this becomes negative 1 over sine squared x. In other words, negative 1 over sine times a negative 1 over sine. I'm sorry, times positive 1, right? So I got negative, and then 1 over sine, cosecant squared. Cosecant times another cosecant. So what's the derivative of the cotangent? Negative cosecant squared. Derivative of cotangent, negative cosecant squared. You could do the exact same process to get the derivative of the tangent, okay? So you should get memorized. Derivative of sine's cosine, derivative of cosine's negative sine, derivative of the tangent secant squared, derivative of the cotangent negative cosecant squared. You can develop all these, right? You can just run, the derivative of the secant, and you could just run the quotient rule, right? And you get that secant tangent, derivative of the top times the bottom minus the top, derivative of the bottom, all over bottom squared. Well, that's gone, and so I got sine x over cosine x, two of these. There's my tangent, and 1 over cosine, so this is tangent, 1 over cosine is our secant, so secant tangent, in other words, right? That we just did that one right there. So anyways, those are the other commonly used trig functions. All right, let's go ahead and find the derivative of the following functions here. F of x equals sine x times tangent of x. Notice we got the product rule here. So when I run the product rule here, I say derivative of the first times the second. I just leave that alone. Plus the first, which is the sine, times the derivative of the tangent, which we just saw the derivative of the tangent is secant squared. Now I want to clean this up. This might not be simplified. So notice cosines cancel right here. So we've got sine plus, and then over here I've got sine over, let me write it this way, sine over cosine, and I've got a 1 over cosine, right? Isn't this the same thing? So this becomes sine x plus, there's my tangent, and then 1 over cosine is my secant. So sine plus tangent times the secant, right? Or if you want to, you could also, let me do it another way here. Could take a sine out of each of these. And then you'd have 1 plus 1 over cosine squared, which is 1 plus secant squared. That's another form of that. Okay. All right, let's do that last one here. F of x equal, or y equals x e to the negative x secant of x. Let me erase this junk here. Set it away. Ugh. All right, so I'm going to think about this as I've got that times that. Okay. Now, I know that there's also a product in here, but that's how I'm thinking about this. So first I'm going to say the derivative is derivative of the first. That's this one. Now, when I take the derivative of the first, I got to run the product rule. So this is going to be kind of long. So I got to take that derivative times the second plus the first, and now I'm going to leave it alone, times the derivative of the second, which we know the derivative is secant tangent. I'll be writing that in just a second. Okay, so let's take the derivative here. Notice I have x times e to the negative x, right? I have a product. What's the derivative of x? 1. So I have derivative first times the second plus the first derivative of the second. Now the derivative of e to the negative x is ln of e to the negative x, and it's not just x up there, so I got to take the derivative of that. That's the chain rule. Derivative of negative x is just negative 1. So this is e to the negative x. ln of e is just 1, right? That's just 1. So I got a negative 1 times x, so I got negative x e to the negative x. And then I've got the secant right here. And then over here I've got x e to the negative x. So this was the first times the derivative of the second. Derivative of the second was secant. Derivative of the secant is secant tangent. Okay, let me bring this up here. Okay, so now we got, once I distribute this, I'm going to distribute this secant through right here. So I got y prime being e to the negative x secant x, and then minus x e to the negative x secant x, and then I've got this x e to the negative x secant x tangent x. Okay. Now notice each one of those, if I factor out, has an e to the negative x, and they all have an e to the negative x. They also all have a secant. I could factor out a secant on each of those. And I'm left with 1 minus x. Oh, see, the x is left over, and then plus x tangent plus x tangent x. Almost missed that tangent there. There's our derivative. Kind of ugly, but kind of cool too. Now, if you look in Canvas on that PDF of derivatives integrals, there's a big list there, right? We just talked about these ones right here. Okay, we just talked about these ones. We talked about those other ones up above there previously, and we'll get into logarithms and all that stuff too. But when it comes to your exam, just make sure that you know your basic differentiation rules. Like these ones should be definitely memorized. Memorize these suckers. Um, all these. These are your basic. You should know those. So when you're doing your homework, try not to reference these. Of course, you can derive some of these as well. Okay, the ones down here will be, you can have those for reference. You won't be expected to know those. Okay, and these ones, again, you can derive with the quotient rule if you want, but we'll memorize them. So thanks so much for listening. We will see you guys next time.